So good morning. All right, I'm gonna go over real quick, infinite, one solution and no solution situations so you guys understand it. Then I'm gonna also go through factoring quadratics for today. So first things first, a one solution situation looks like this. 12 plus 2x minus x equals 9x plus 6. So here's my marker. Go ahead and solve it like you normally would. Complete like term or combine like terms. 12 plus x equals 9x plus 6. I'm going to subtract x from both sides. I'm also subtracting 6. So 6 equals 8x. Divide by 8, and you're left with divide 2 on top and bottom. And I get 3/4 is your final answer. That is one solution. All right, when you get an actual number answer. Okay. There's your one example. I'm going through this kind of fast, so pause it, take notes, rewatch it, whatever you got to do. There's your one solution situation. Now your no solution situation looks like this. 4, we got 2x plus 1 equals 5x plus 3x plus 9. So first things first, carry out the distributive property and also combine like terms. So I got to do this times this times this. So I got 8x plus 4 equals, combine like terms, 8x plus 9. Now you would combine your like terms, right? But I'm only doing this because you'll see something. Your 8x will cancel off on both sides. You're left with 4 equals 9, and we all know that 4 does not equal 9. Therefore, this is a no solution situation, which ultimately means I can not plug in a single number for x and make both sides equal each other, okay? No solution also looks like, if you were to graph both of these equations, the 8x plus 4 and the 8x plus 9, these lines are parallel, so that means they will never intersect, okay? And I'm sorry to go back to this one. The one solution situation means that these lines will intersect only at one place on the coordinate graph. Now an infinite solution looks like this. 3/2 2x plus 6 equals 3x plus 9. So multiply out, do the distributive property. 3 times 2 is 6. 6 divided by 2 is 3x. 3 times 6 is 18. 18 divided by 2 is 9. Look how your left side and right side are identical. In this situation, that means every single value for x, no matter what it is, from negative infinity to positive infinity, your left side will always equal your right side. And what does this look like on a graph? These are both the exact same line. They overlap each other. So we'll be back in a second with some other examples on factoring quadratics. All right, so today we're going to be looking at these type of puppies, and I'm going to do a couple examples here. First things first, this is quadratics. These equations we started working with last week when we were doing FOIL. The week before, specifically, these are called quadratics. How do you know it's quadratic? Because the leading power is 2. Now, how do I factor this? Well, I got to put this into factored form like this. And when the leading coefficient, and by I mean the leading coefficient, I'm talking about this x squared, is just 1, these are really simple to factor, okay? Because I know x times x is x squared, okay? The next thing I look at is I see a plus and a plus here. When I see a plus and a plus, automatically go in and put a plus and a plus. Now, here's how you factor this quadratic. You got to ask yourself, what multiplies to 18 that also adds to 9? Well, 9 times 2 is 18, but 9 plus 2 is 11. That doesn't work. Okay, 6 times 3 is 18. 6 plus 3 is 9. Here you go. It doesn't matter where you put each number. It just matters that you got them there, because when you carry out FOIL, x times x is x squared, x times 3 is 3x, 6 times x is 6x, 3x plus 6x is 9x, and then 6 times 3 is 18. Going on down. Let's do this one, okay? Now I got another one. Leading coefficients x, very simple, x and x, okay? Plus and plus, plus and plus. You'll see why this is important later on, okay? What multiplies to 6 that adds to 7? Very simple, 6 and 1. 6 times 1 is 6, 6 plus 1 is 7, good to go. Last but not least, and then I'll do some more examples in a minute, I got x here, I got x there, okay? What multiplies to 16 that adds to 10? Well, 16. 4 times 4, 4 plus 4 is 8, no good. 8 times 2 is 16, 8 plus 2 is 10. Very simple, 8 here, 2 here. Those are the basics of how to factor quadratics. I'll be back in a second with some other types of examples. All right, here are my last 3 examples for today. So now I got a minus and a minus situation, and here's how your mental math has to take over. We know that this is going to be into factor form like such. I know the very first one is easy because this is x, 1x. So this is x here and x here. Now, here's the problem. I got a minus here and a minus here. Look at this first, this negative 12. This is crucial because the negative 12 means you have to have multiplied a positive times a negative. Because you had to multiply a positive times a negative, I'm going to put one of them a plus, one of them as a minus, okay? Now I got to think, what multiplies to negative 12 that also adds to negative 4? Well, negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. That's not good. Let's do another one. Negative 2 times 6 is negative 12, but negative 2 plus 6 is positive 4. Okay, so then I have to reverse them. So I'm going to do the bigger number negative and the smaller number positive because I know the same difference. Negative 6 times 2 is negative 12, but 2 minus 6 is negative 4. There's that one. Now down here, I got another one. Easy, first step. Now this is where this one's kind of simple because I got a positive product but a negative sum. By rule, I have to have a negative and a negative there, no matter what, okay? So, what 2 numbers multiply to negative 12, positive 12, that add to negative 8? Well, that's kind of simple. Negative 6 and negative 2. There you go, we factored it. And last but not least, let's do one more of these. Again, very simple, will get more difficult as time goes on. I got a negative product and a negative sum. Okay, so let's change this around a little. Let's just say I had a positive sum. Let's say I had that instead. Okay, just for grins. Let's just show you how to think differently about it. What multiplies to negative 22 that adds to positive 9? Well, I know I got a negative and a positive. Doesn't make a difference where you put which one right now, but it will later in other stuff we do when it gets more difficult. So I know a negative 11 times 2, but negative 11 plus 2 is negative 9. So I'm going to do a negative 2 and a positive 11. Be aware of that, please. All right? So I will see you guys in class.